Hey guys, how's it going? Welcome to the part 4 of Python Pandas tutorial series. In the last couple of videos, we have seen how to create a series and a data frame in Pandas. So once we load data in series or tabular format, that is data frame, what next? Probably we need to visualize the data. We want to see the data. We want to get an overview of what this data is all about. In order to do that, there are a lot of methods and functions available in the Pandas with which you can get some overview of the data. So in this tutorial, we're going to talk about that one. So let's get started. Okay, so here we have imported pandas and numpy, and then in the next block of code, we are creating a series which has 1000 element in it. And loading 1000 element one thing, and printing into the GUI is different thing. So we probably don't want to see the entire 1000 element of the long series. So to view a small sample of series or data frame object, please use head and tail method. The default number of element to be displayed is 5, but you may pass the number which you wish for. So let's do that thing. So here I say long series and then head. So now if I will just go ahead and run it, you will see by default it gets 5 element printing from the top. Now if you want to get elements from the bottom, use the method tail. So again, here I will say long series dot tail, and by default it is 5, but if you want to print any arbitrary number of element, then pass that one here. So we will pass, let's say 3. In that case, it will print 3 elements from the bottom. Okay, cool. Now let's talk about how to get an overview of the attributes. Pandas object have number of attributes enabling you to access the metadata, and we're going to see few of them. The first one is obviously the shape, and for that let me create a dictionary of another data frame, and I would do that using our dictionary data. And if you want to know more about this one, please refer to my previous tutorial. So here I will create one and pass a list into the first key item of the dictionary: 1 point, 2 point, 3 point, and 4 point. And then I will create the second column, which is 2, and against the key 2 I will pass 4 dot, 3 dot. I'm just reversing the order. Okay, 1 dot, and that's it. So let's pass this data into a data frame method. So df equal to pd dot data frame, and then I will pass here d, and let me also give the index name. Index equal to a, b, c, and d. Okay, now first print the data frame. Let's print the data frame. So this is how it look like. It has 2 columns and 4 rows. Okay, to get a bit of overview of shape, what you need to do, you need to get access to shape attribute saying df.shape, and let me just type print in the beginning. Now here you get the shape attribute, which is 4 rows and 2 columns. Okay, similarly, if you want to grab the size of the data frame, that is the number of elements that are present within the data frame, you just say df dot size. In that way, it will get you can grab the size attribute of the data frame, which is 8 in this case, and in a way you can multiply 4 into 2, which is the shape attribute, and you will get the the size attribute of a data frame. Okay, now let's talk about how to get the axis. Now if you grab the axis attribute, in case of series you will get the index only, but in case of data frame you will get both index as well as column. So let's first print or grab the axis item of the series. So long series which we have created in the first place, in the first block of code, and here I will say axis. Okay, now if I will just go ahead and run it, you will see you get the axis item that is range from 0 to 1000. Okay, then I can also grab the axis item from a data frame. So I will say df.axis. Now in that case you will get both the axes. So row item, which is A, B, C, D, which is index, and the column item, which is 1 and 2. Okay. You can explicitly ask for axis index and the column by grabbing the df.index attribute and by grabbing the column attribute. You can get both index and column explicitly in a different code. So if I will just run it, you will see in the bottom part you get actually the first one is the index, the second one is the column, or else you just ask for axis and that way you will get both the item. Okay, now let's talk about how to get the value. To get the actual data inside the data structure, you need to access the value property or the value attribute. So here you can say print and df dot values, and if you run it you will see you get the data frame, but right now it's not a data frame anymore, it's just an numpy array which has a save of 4 rows and 2 columns. Okay, now though we have seen how to visualize the data and also we have grabbed some of the attributes, key attributes of the data frame in the series, the next thing probably we want to know is about descriptive statistics. And there is a large number of methods that exist within Pandas with which you can get the descriptive statistics of the data frame of the series or the series. But most of the methods are aggregation. Hence, it produces lower dimension results. So if you pass the data frame, it will give you the series. If you provide the series, you will get a scalar value or one item value. So most of these aggregation methods are sum, mean, quantile, etc. But some of them are like cumulative sum or cumulative product, which intact the dimension. Okay. And generally speaking, these methods takes axis as an argument. These aggregation methods like sum, mean, and quantile. Okay. But series you don't have to provide any access to it. But for the data frame you have to provide the access. In case of if you want to grab all the items of the column, then pass 0. If you want to grab all the item of the rows, pass access equal to 1, which is pretty standard. Okay, first by default it's access is 0. So first let's see the example. Say print, and let's grab the mean method of the data frame, and by default it's 0. That means you will get the mean against each of the columns. So now if I will just go ahead and run it, you will see you get the mean of the two column 1 and 2. So x is equal to 0. You will get the similar result because by default it's 0. If you want to grab the mean against each of the row, then pass x is equal to 1. In that way you will get the mean against each of the rows. Now all such methods having a skip NA options. Okay, And the skip NA is by default true. If you don't want to grab the skip NA, you explicitly say, if you don't want to skip the NA value, you want to explicitly say skip NA equal to false. So here you say df, let's take another example, which is sum. In this case, I will say x is equal to 1. In that way, I will grab all the items I want to get the sum against each of the rows, and here I will say skip NA equal to true. So this is the by default value. If you don't want the skip NA, currently we don't have a NaN value in the data frame, but if you don't want to skip this one, you probably say skip NA equal to false. And why you need to do that? In case if you have a NaN value within your data frame, and if you perform this kind of uh, sum methods and you say skip NA false, you will get NaN value as a result. So in that way you will get to know whether whether a row or column they do have a NaN value or not. So kind of get a flavor how much NaN value you have in the data frame. You can also combine the broadcasting operation along with the arithmetic behavior, or the vectorized operation or element based operation, and describe your various statistic procedures. For example, if you want to calculate the standardization across for each of the elements of the data frame, uh, so probably it look like some some fancy thing I'm doing, but don't worry, you will get to know about this particular thing when we will talk about data science in detail. So we do lot of standardization across rows, across each of the column. The region is different. I probably would give you right now, but it will not make any sense. But we do such kind of operations. So what we do in short here, we just take the mean against each of for all the columns, then we subtract that mean against each of the items, then we divide uh, sorry then we divide the standard deviation of each of the column. So in that way you will get this standardized value of the data frame. So let me print it out. Okay, so you can mix and match all these operations. Okay, so there are few examples which I'm giving here, but there are many things which you can do. Like you can count, you can use median, mean, max, mode, many things. And I will give you a bit of overview in the website. You can go there and get the detailed list of the function that you can use or method that you can use on the data frame or the series. Okay, now quickly we will go to how to get the summary of the data, and there is a convenient describe function which will compute a variety of summary statistic about a series or a data frame. Okay, now this will again exclude the NaN value. So if you just say df dot describe, and this method will give you the descriptive statistics kind of thing. So basically you will get like how many item present for each of the columns, mean, standard deviation, minimum value, then quantile and the maximum. So this kind of things you can get by using one method, which is describe. Okay, the last method which we're going to talk about is called value count method, and this value count methods and is a top level function which compute the histogram of a one dimension array of values. Okay, and it can also be used as a function on the regular array. So let's see the example here. So let's create a series np dot random dot rand int. Here I will say 0 to 7, and I want 50 elements. Okay, and let's first print this series, and this is how it look like. Okay, now let's create the series here. So s equal to pd dot series, and then I will pass this data here. Now to get the histogram kind of value count, you say s dot value and then counts, and if I will say enter, and here you will get for each of item, it will just count how many time it appears in that series. So in that way you will get the feeling, in case of if you have a categorical data, you will get the feeling how many time a particular value is appearing in your data. Okay, that's where we will take the pause. In the next tutorial, we will talk about how to read and write data frame from different file format. As usual, if you have any question, please feel free to drop your questions comment in the comment section, or else thanks for watching. Thanks for all your likes and subscription. Until next time, cheers.